Hi everyone. It's a pleasure to have you all here for this very exciting session on network slicing on Amantya's 5G core. Your participation is indeed very much appreciated. I am Akash Goyal and I head the marketing activities at Amantya. I'll be moderating this webinar today. Taking us through the live demonstration will be Indranil Dev, who is the AVP and heads the 5G product portfolio at Amantya. Gaurav Sharma, who is the AVP and heads the engineering part. And Neeraj Sharma, who is the senior testing engineer at Amantya. The session will be of around 45 minutes. We will be opening up the chat window at the end of the demonstration to take your questions. So without any further delay, I will now hand over the floor to Indranil. So Indranil, you can go ahead.
Okay, all right. So what we plan to do today is that we'll be for people who are joining us for the first time, we'll be doing a little small introduction of the organization that we are a part of. And then we will talk a little bit more about the Amantya proposition on network slicing. And we'll be focusing on various aspects of network slicing, such as the charging aspects and the aspects that are related to the aspects related to the slicing automation and things like that. Uh, so who are we as an organization, right? So we are Amantya Technologies. We are a product engineering services and system configuration organization. And we focus primarily on the wireless and connectivity domain and the digital services domain. In wireless and connectivity, we work across various domains such as RAN and core, and focus on different technologies such as 4G and 5G. In the digital services space, we focus primarily on software development projects and cloud services, AI/ML projects, and so on and so forth. And inherently, as you can see in the slide, that is how we are organized. We are a group of 350 engineers, and we are based in India and in the US. The verticals that we focused on are telecom, no surprises there. And we also do a lot of work in the automotive, retail, and healthcare segments. So let us talk about the Amantya slicing proposition. This is what we wanted to speak with you about today. The Amantya slicing proposition, as you can see in the slide here on the diagram, is encompassed in the orange box. That is the area where we play. The slicing solution that we have for Amantya is best suited for enterprises, as in private networks, network deployments, and simulation environments. For private networks, for example, in enterprises that want to have different slices deployed within their premises for different use cases, those are the kind of use cases that our slicing proposition would be best suited for. And also in the simulation space, we want to help organizations that want to set up labs for testing out network slicing for their end-to-end for their use cases. The slicing solution that we bring to the table essentially includes two components majorly. One is the management services part, which in 3GPP parlance includes the NSMF and the NSSMF, which is one is the network slicing management function. The other one is the network slicing subnet management function, which together make up the management interface of network slicing. And the second component is our 5G SA core, which has network slices enabled in it. From a compliance perspective, the slicing solution that we have, it complies to all the major 3GPP standards that are related to network slicing. From a management perspective, which essentially talks about the implementation of the NSMF and the NSSMF, we comply with 28.533 standards. Then there are a couple of standards on charging management and charging support in the 5G core. There are standards; those are the standards that we comply with as well. And finally, for performance and KPI control, which basically deals with the performance KPIs that are monitored and processed at the NSMF and the NSSMF. Those are defined in standards to 28.550 that we also have are complied to. From an ecosystem integration standpoint, the slide, as you can see in the diagram here, we operate on the management services and the core part. But the slicing solution, as many of you are aware, has a lot of moving parts other than these two. So there is the OSS BSS, there is the converge charging aspect to it. There are infrastructure managers as well, and the RAN and transport. So it is very important for any slicing function to have these interfaces enabled, which are standards based, of course, so that the integration with the rest of the ecosystem components becomes easy. And that is something that we also enable in our solution. In the deployment and the management part, so our solution is fully cloud native, which means that you can deploy it in a public cloud or a private cloud as is the requirement. It is Kubernetes managed, and it is an out-of-box distributed deployment. What this means is that the deployment, since it's Kubernetes managed and fully cloud native, can be deployed. The deployment becomes very easy, just a click of a couple of buttons and the solution gets deployed. And there is intent-based deployment also, which means that you can deploy it based on how your network topology actually looks like. The solution is also accompanied with a management interface for easy interaction with the different components that make up this solution. And we are also integrated with ONAP. ONAP, as you know, is an automation standard that is quite in vogue in the telecom industry today. And they have their own slicing implementation as well. So they expose these APIs that we kind of consume and are integrated there. So in a nutshell, the slicing proposition that we have are essentially targeted for enterprises for the simulation market. And some of the important aspects that I think we should highlight here are that the solution has APIs for easy integration, which means that it can become a part of any incumbent ecosystem with a minimum of effort, integration effort. It complies to standards, which basically again ties back to the fact that it can be integrated with a lot less effort than other solutions. And the out-of-box distributed deployment point that I described makes for fast deployment and quick uptake of the solution. Now moving to the next part, this is how typically this is what slice automation typically looks like. Now, when I say slice automation, what exactly do I mean by it? So this is more to do with the fact with how an end user, would interact with the system when they would be wanting to use slices that you would have configured in your platform, right? So there are a couple of steps. There are some steps that need to happen before the slice can be ordered and consumed. And the slice automation framework essentially attempts to automate all of those steps so that you could have a scenario where a user could order slices off of a drop-down list, and that slices gets deployed and configured in the underlying infrastructure and becomes ready for operation just by the click of a few buttons. Various steps here, as you can see in the slide. The ones that are highlighted in red are the ones that are enabled by the solution that we offer. So the first step essentially is GST generation. GST stands for generic slice templates. Now, these are templates that are typically used by customers to provide requirements to CSPs or carriers on how they would like the slice to look like and what kind of performance KPIs they would want the slice to sort of address. The second step would involve converting of those generic slice templates to network slice templates. Network slice templates essentially are consumed by the system itself in the sense that the GST, the generic slice templates would have generic requirements, and they would be interpreted by the system into, let's say, a core requirement or a RAN requirement or a transmission requirement, and that network slice template would be sent out to the various domain controllers for instantiation. Which brings us to the third step in the process of instantiation. Once the network slice template has been created, the instantiation process can then happen. The next step and the one after that regarding order fulfillment and catalog. Now, these are two steps that are closely related to each other, and they are optional steps in the sense that if a customer wants a slice template that is not configured in the system, the automation framework essentially allows you to on the fly get that added into the catalog so that it can be available for one-stop, one push, one button click deployment for future customers. And once the catalog has been updated, an indication can be sent back to the customer saying the order has been fulfilled. And after that, the process can enter an operation phase where SLAs and closed loop automation is used to monitor the performance of the slice and make course corrections as and when needed. Now, talking about the charging aspects. Now, how would you charge the slice? This is also of a lot of interest to customers, particularly carriers that are looking to sell these slices as a service to their end customers. And now 3GPP provides a very, very straightforward sort of implementation for charging the slice. And if you look at the diagram that is on the top left corner of your screen, you would see a very simplified view of what the architecture currently looks like. And I have also earmarked what the domain that we sort of operate in and what are the domains that we integrate with. From a charging perspective, there are three major components to the charging aspect. There is the network slice management function. There is the core network function, and then there is the charging function itself. A slice can be charged based on multiple aspects, right? So you can charge a slice based on either usage data that is transferred across the network, or the slice can also be charged or rated based on the performance of the slice. Now, performance of the slice would essentially mean slice KPIs such as latency, mobility, and etc. So, and charging can also be enabled based on actions that are done on the slice for creation, activation, termination. All of these aspects are important because they are all used by slice users and slice providers, as you can see in the diagram below, to charge the different types of slices that are offered, which could either be a private slice, which is used by a single customer, or a shared slice, which is shared across enterprises, or you could have a scenario where you have one customer that is using multiple slices. Now, Amantya's play here is primarily the network slicing management function, which is essentially used to monitor the management activities that are being done on the slice, and therefore implement or trigger the charging function accordingly for charging activities. And then you have the core network function, which typically would be the SMF that would monitor usage on the data plane and would trigger the charging function to charge based on usage. Some of the network slicing use cases that are typically that typically we come across, and I have sort of segregated these use cases based on the kind of slice that would be needed to service these use cases. So there is private slicing, as we talked about, where a private network deployed on an enterprise where a slice is used for one purpose alone, and those use cases could be object detection in surveillance and in health and safety use cases. Then there is a shared slice scenario where enterprises share the same slice, and you could have online gaming and streaming services that are done using shared slicing. And then there is the multiple slice scenario. You could have big enterprises such as a smart grid or oil and gas companies, which would need multiple slices to service their use cases. For instance, in a smart grid, you could have multiple sensors that are deployed all across their networks. You could have one slice servicing the smart the sensors, and you could have another slice that would be servicing the IT or the IT needs of the organization itself. So that at a very high level is what is the network slicing proposition that Amantya has from a management and an implementation perspective. And now we would move to the demonstration that we have planned for you today, where we would be talking about the implementation of network slicing in our own 5G SA core. And for that, I'll hand the stage over to Gaurav for him to take over.
Thank you, Indranil, for that introduction. Uh, so good afternoon, good evening, good morning, friends. So what I'll try to do today is probably give some more or add some more color to this conversation that Indranil just had with all of you, and probably talk uh, about few things more in engineering perspective, right? Because when we talk about slices from a core engineering perspective, what does that represent, right? And how is that it makes a lot of sense for operators out there to actually have this thing as a part of their offering, right? I'll talk about few examples that will help you guys actually appreciate what are these actually what do these slices actually stand for. And again, from a demo perspective as well, we have something lined up for you to talk or to help you appreciate these concepts a little bit better. Okay, so what we'll do today is we'll be talking about two slices, right? And when I talk about two slices, what I actually mean is that two very different network experiences or two very different network architectures, in the sense that what are the use cases or the services these networks or these virtual networks, if I may call them, offer to the end users, right? Think about it that you need a network which has very low latency in it, right? So it may be a network that may be out there supporting V2X scenarios or certain other very critical ultra reliability scenarios, few things on the medical domain or certain things on the automation side, right? That are very, very sensitive to latency and need networks that actually are actually support these use cases, right? So that's one type of virtual network. The other type of virtual network may be ordinary mobile users, right? You may have, and here what about ordinary mobile users? What we are referring to is a very large number of users out there who are a little bit more tolerant to latency. But if you look at the number of these users, that is huge. Right now, these are two very classic use cases that the operators typically would be looking at. Right now, again, slice one, it's more about the dynamic dimensioning, the speed, the latency, and whereas slice two, it's more about static dimensioning, where you have to support a number of uh, subscribers, though they're a little bit more tolerant or about the speeds, right? So the slices that we have built in, right, for this slice one, this is again using the network topology that actually facilitates high speeds. So the UPF is, or the user plane function, that is installed in the cloud, in the Gnode B cloud, which means that it's closer to the end user. The throughput machines and the NIC cards, they support very low latency scenarios. So these are high speed machines. Even in terms of uh, the machines where AMF, where these various nodes are deployed, the core 5G functionality, they are nodes that are built with the high speed network, right? Slice 2, it's wherein you see, and what we have tried to show in this diagram as well. Slice 2, here you don't see the UPF being installed in the same cloud network where the G-Node B is. So it's a little bit distant from that, and it's part of the core network. Right now, of course, there are costs associated with each and everything, but then there are advantages as well, right? Moving to the next slide. Here, what I wanted to talk about is when we talk about a particular slice, right? From a data perspective, right? What is the relational model between all these different nodes, right? How do we identify a slice, and how does the user actually come into picture? How does his subscription actually get impacted because of these slices? Now, primarily what we have done is, again, from an ease of understanding perspective, I'll keep it at a fairly high level. Uh, so there are certain slice parameters that actually define the slice type and the slice descriptor. Now, these are again standard terms that come from 5G. Now, for each of these slice, there are standard attributes that get populated as a part of provisioning. Now, once you have configured a slice, the next step is you need to assign different nodes to this particular slice. Now, here you can have one single node, which is part of multiple slices, or you can have nodes that are dedicated to a slice. Of course, for today's demo, what we have done is the AMF, SMF, UPF that is dedicated to a slice, whereas the remaining functions, right, UDMs, PCFs, etc., they are shared between all these slices, right? So from an engineering, from a deployment perspective, the solution that we have, we can configure it in all these different manner, right? So as to come up with different deployment strategies. From a user perspective, of course, his subscription that contains the list of subscribed slices. And at the end of the day, the the actual slice that a user gets, that's a function, or that's a combination of his subscribed, requested, and available slices within the network, right? Uh, as I said earlier, uh, again, from an operator perspective, when we talk about slices, these are all virtual networks, right? But then how do these actually relate, or how do these actually get overlaid onto the physical network, right? So here, the deployment model that we have for our solution, as Indranil also pointed out at the beginning, this is based on Kubernetes, right? Kubernetes gives us flexibility to deploy our network nodes or our functionality in various forms, right? What we have done is cleverly using the Kubernetes features to actually partition slices. And when I say partition slices, uh, the the thing that I want to highlight again from an operator perspective, it makes perfect sense. So you have a single machine. What you can do is you can partition the various resources of this machine into different slices, right? So again, coming or taking a cue from the example that I just mentioned about, say you need a low latency slice, right? Which means that your CPU usage or your memory usage is higher. So what you can do is on a single machine, the slice that we provision, what we will be doing is we will be allocating a higher percentage of the CPU or the resources to this slice, right? Whereas for a slice that is tolerant to some delays or has a different characteristic, what we can do is we will be assigning lesser number of cores and other resources to this particular slice, right? So this actually gives you a very easy way, a very predictable way of implementing these slices over a common infrastructure or over a common physical machine, right? So even though these virtual networks from an end user perspective, they are quite different in their nature and their behavior, but then from a physical deployment or installation perspective, they are running on same machines, right? And I mean, some of these slices, again, these slices that we have configured today, the slice 2, we have configured it in a manner where the number of CPUs and other resources, we've limited that to a lower number. Now, the important question then comes is that, okay, we can do all these things, but then how do you actually provision these slices? Again, Indranil touched upon some of these things earlier in the conversation, but again, from a core engineering perspective or talking about the actual methods that we use, so there are various ways of doing this thing, right? And we have hooks within our solution or our deployment. Uh, Wherein we can actually integrate with any third-party OSS or own app based or potentially other similar based provisioning systems using Helm charts, using certain other Kubernetes scripts, right, or our own homegrown solution as well, wherein from an operator perspective, he can specify, okay, that this is a new slice that I want to build. These are the kind of resources that I want to give this particular slice. And while provisioning subscribers, he can specify that, okay, this particular subscriber goes to this slice and so on, right? Uh, Another requirement that potentially can come from the operator is as well as counters and KPIs, right? You may want to see how heavily loaded one slice is, or how or what are the performance characteristics of a slice, right? So again, here counters, KPIs that we give, you can tune them for a slice and see the actual characteristics, right? Again, the deployment model, and again, some of these are low-level details. The way we make these slices in Kubernetes, that gives us a lot of independence. Even though the infrastructure is common, to actually finally manage these slices, right? So say, for example, if I need to upgrade a particular slice, right? So if I need to do some changes in a particular slice, right? There is a sudden requirement that comes that, okay, this slice was used for, say, for subscribers who were more tolerant to latency, but somehow, because of some reasons, now you need to add more resources to it. So the way we have architectured this whole thing within our deployment is that without impacting other slices or without actually causing major downtimes in any of these other slices or this slice as well, you can just go ahead and update, modify a particular slice in itself, right? So these are some of the advantages that we thought that, yeah, from an operator perspective, it makes perfect sense to actually be able to manage these slices, monitor these slices, perform certain operations, upgrades on these slices. The whole idea is that we view these slices as fairly independent networks, even though they are part of the same physical infrastructure, right? That's a short description of our implementation, the way we view these slices, some classic example of how slices would be tailored by the operator. And of course, as I mentioned earlier, the deployment model that we follow, it's fairly flexible in the sense that you can have a very differentiated networks, sliced networks within your physical infrastructure, right? Now, with that, what I'll do is I'll request Neeraj, who's a part of my team and who has had experience on these slicing implementations as well, to give us a small demo. In the demo, what we will cover today are, as I mentioned earlier, there are two slices. So first, what we'll do is we'll do a registration and PDU session activation on slice one. What we'll talk about again at a fairly high level is that what are these messages that are exchanged between the UE and the network. For UE, we will be using our simulator. And then we'll repeat this operation on slice 2. And again, we'll see these messages and probably talk and probably take some more questions from there on. Okay, Neeraj, it's over to you. And once you're ready, just let us know.
Okay, so hi everyone. So I'll be giving a short demo on the slicing, right? So I'll be sharing my screen. Yeah, is my screen visible?
Yes, Neeraj, we can see it.
Okay, okay. So I'll be executing a test case which will have the registration and PDU session establishment procedure in it. Okay, and then I'll show you the UE registration first on the slice 1, right? Then I'll show you the same user getting registered on another slice, right? So I'll be executing the test case from the gnode B. So the test case has started. So this is the system log that is getting generated for the particular test case, and parallelly the traces are getting captured for uh, Wireshark, right? So that we can check that pcap log file inside a Wireshark tool. So let it run completely, then I'll show you the captured file, and I'll go through the traces for the slicing messages. Yeah, so the complete test case is complete for the registration and PD session. Now let me open the traces of Wireshark. Let me filter out the required protocol. And so this is the first message that is going through the gnode B to the AMF for the ng setup request and response, right? So these are the basic messages that goes between the RAN side and the core side. So I'll just directly take you to the message where user is sending the slice information, right, in which it wants to register itself. So this is the message: uplink NAS transport security mode complete with registration request. Inside this message, a particular UE sends its requested slice details. So I'll expand this message. I'll show you the item element, information element, where it sends the slice detail. So this is the information element NSSAI requested NSSAI. Right here, user has sent 3 slice details, right, on which it wants to be registered. So this is the first slice, this is second slice, and this is third slice, right? Then it is sent by UE to the AMF, right, in the core network. Then further, AMF takes this and request the NSSF, right? So this is the another message. This is HTTP protocol message. So this is sent from AMF to the NSSF. Here we can see. So AMF has sent all those 3 slices which were requested by a particular user or a UE, right, for it to be registered on. So then AMF requests the NSSF to let AMF know that which out of those slices which are allowed slices and which are restricted, right, or rejected slices. Then this is the response from the NSSF here, as you can see from the traces. So NSSF has sent the allowed slice detail here inside this allowed NSSAI list. So you can see this first we have out of those 3 slices, D1 see SST1 SD as 0000D1. This is the slice detail which is allowed here, and the rest two slices, if you will see here, this is the rejected slice, right, list. So these two slices are rejected, right? So user will be allowed to register on only this slice, not on these slices, right? So this is, and here it's also sending, NSSF is also sending the target AMF set which are supporting the allowed slice to which a user will be registered. So if I'll go back here, so after this, NSSF will provide the slice allowed slice details to the AMF pack. Then AMF will check, right, it's supporting that slice which the user has requested for. Then further processing will happen, right? And when we'll check the registration accept message, where an AMF is sending the accept for the registration to back to the UE. Here you'll see, when I'll open it again, you'll see a user has been registered and it has been accepted over this particular slice. So if you'll check this IE, information element allowed NSSAI, you'll see this D1. Yeah, right. Here you'll see SST S01 SD 000D1. So on this slice, particular slice, a user has been registered. Okay. So further, if you'll check registration complete happens here, then if you'll check the PDU session establishment request, then for the PDU connectivity, when a UE sends that request to AMF, and if I'll open this message here also, for registration, as you have seen, user had requested for 3 slices, out of which D1 was selected, and then it has registered over 0000D1 slice. Then UE has also requested for the PDU session establishment over the same slice. Then this is the converted values, right? So this means it has requested for 0000D1 only for the PDU session. Then if we'll after further processing of the HTTP protocol messages, right, between the core network only, then if we'll check the accept message, PDU session establishment accept, which is this message. If we'll open this, then we'll see that user has been established with the PDU session over the same requested slice. So if I'll go down to the information element of slice, so here you'll see user has been established with PDU session over this slice only, for which it has requested, which was allowed by the NSSF. Right. So this 1209 is the converted value for that 0000D1 slice. So like this is the registration and PDU session establishment procedure for a particular UE over a particular slice for which a UE has requested. So this is the trace, and I have shown you the execution. Now over to Gaurav once again for the further explanation.
Right. Thanks, Neeraj. So, I mean, again, talking about it at a high level, uh, the exact message flow. I mean, there are deeper or more involved details onto that. But yeah, uh, typically a standard flow would be the end user actually uh, configuring from his mobile the slice that he wants to use, right? So say, for example, uh, I am a subscriber of low latency network, right? And I want to use the slice one. So within the UE's configuration of, so I can subscribe to multiple slices, by the way, but for a specific use case, what I'll do is I'll pick up a slice, say one, that corresponds to low latency network, and send the message to my network saying that, okay, I want to register on slice one, and my PDU session should also be made on slice one so that I can get the required set of services. The rest part of it is the magic happening within the 5G network itself. Of course, there are two levels in it. One is, of course, the standard messages, uh, right, in it. The other is on the deployment part of it, right? So the way we identify the nodes, the way these nodes get implemented on the Kubernetes setup or cluster, and the way resources are given to these nodes, right? So that is where if you If you overlay these two things together, the standard message flows plus the IT architecture of each of these slices, that is how you actually get this potent combination of the network actually giving you the required KPIs plus the user accessing this network, right? Of course, there are some finer level specification details. Probably today isn't the time to go into all those details, but at a high level, this is what I wanted to talk about. Neeraj, would you want to show the registration happening on slide 2 now? Slides 2 now? Neeraj, I think you are on mute. I'm a little bit mindful of the time as well.
Yeah, sure. Sorry for the
Yes.
delay. So let
No
me show you
issues.
the,
Right, and
yeah,
probably we'll just run through that a bit quickly. I'm mindful of the time.
sure, sure.
And then we'll take one or two questions as well after this. Neeraj, we'll just show the initial registration messages, the new slice number going in it, and in the accept message, the accepted slice number.
Mhm. Sure. So let me take you through the execution of the UE through the second slice, right? So here I'll just run the test case with the same registration and the PD session establishment, right? So this is the background logs which gets generated on the UE side for that particular test case. And the trace will get captured parallelly, right, for the recap file to be generated and viewed in the Wireshark. So this is the call flow, and let me show you the Wireshark traces for that. Yeah. So if you guys are able to see, then let me show you. So for the UE on the second slice, right, for to be registered on the second slice. So UE, let me directly show you the request where UE is sending. So this is the security mode complete with registration request. Here, let me show you. The UE has requested for now the different slices, right? So let me take you to the slice requested slice IE. Here earlier it was 209, 10, and 11. Right now it's SST1, SD213, 210, and 211. 213 is 0000D5. Earlier 209 was 0000D1. This is the converted value, right? Value gets converted between hex and decimal values, right? So this is the requested value from the UE for a particular slices. Then AMF will get again to the NSSF for getting the information, right? Which slices out of those are requested and which are rejected. So let me show you. Yeah, so from the NSSF, this is the response in blue. So allowed slice this time is D5, right? Earlier it was D1, and the rejected slices are same, D2 and D3. Out of those three, one is accepted, two are rejected here. So UE will, so AMF supports this allowed slice. So then AMF will register the UE, right? Then if you'll see the accept message, registration accept, then you'll see the user has been registered over this 0000D5 slice, right? Which is allowed from the NSSF for this UE. Then similarly for the PD session again, you'll see the slice requested from the user is 213, which is 000D5, and then accepted slice by the core network will be again after the PD session gets established for that particular UE. So that PD session will get established over this same slice 213, which is 0000D5. So this is the Wireshark trace for that call flow, right? That's it from my side for the execution part. Over to you, Gaurav.
Thank you, Neeraj. Thank you for that demonstration. Probably we can now jump to the next section. Akash, if we have any
Sure,
questions.
sure.
Yeah.
Yes, I have now opened the chat section for all the participants. So we'll take a couple of quick questions before we end this webinar. So you can post your questions in the chat section. Okay, so the questions have already started pouring in. So the first question which we have is from Chris Anderson, and Chris wants to know what are the various ways in which a slide can be defined in an infrastructure. Can we have slices using the same infrastructure and servers?
Okay, probably I'll answer that. So absolutely, yes. I mean, if you look at the whole concept of slices, right, it's you can compare it with a virtual network, right? And what a virtual network would do or would be implemented on are on shared physical servers, right? Uh, Now the deployments that we have in even the deployment that we used today for demo, we have a we have set of common physical servers on which we are running 2 or 3 different slices, right? Uh, since the solution is based on Kubernetes, what we can do is we can very efficiently uh, divide these physical servers into independent units, if I may call them, to actually run these slices, right? And as I mentioned earlier, the level or the granularity level where we can go is quite low, which means that we can partition these slices even till the resource level, right? So say, for example, I have a physical server that is, say, a 16 core machine. I can make slices. I say I can make 8 slices of 2 cores each, or one slice of, say, 10 core and another slice of 6 core, or any other possible combination. Yeah. So that is something which is the very basic of how this slicing works. Yeah. I see there's another question coming in.
Okay, there's another question from Aviral. So what he's asking is, does Amantya support the provisioning of new slices in the network from provisioning systems, and how is it achieved?
Sure. So yes, this is again one of the basic requirements that any operator would have, or uh, a network would need to support. There are various ways in which slices can be provisioned. Uh, I mean, we follow standard ways of configuring slices, as I mentioned earlier. There are various mechanisms possible. Helm charts is something which we use, and these charts can then be integrated with so many third-party provisioning systems, wherein the operator can tell that, okay, I need to create a new slice. These are the kind of resources that I need to provide to the slice. And yeah, and once the slice is configured and up and running, the provisioning systems are then informed that yes, these slices are done, and now you can start assigning subscribers to this slice. Yeah.
Thanks, Gaurav. Gaurav, I think we're already running out of time now, and I think we just have these couple of questions for now to answer. So if there's any question from any of the participants, we will answer them offline definitely, and I'll be sharing the recorded session with everyone post this webinar. I thank you everyone for the participation. It was much appreciated. Thanks, Gaurav. Thanks, Indralil, and thanks, Neeraj, for the presentation. Thank you, everyone.